All right, year 11s. This is another question for 5G, inverse functions, and question 6. Question 6 here tells you using function notation is saying there's a function with the letter f where the domain, so this represents domain, the domain is all possible values, maps onto the codomain, which is R, and technically you can ignore this part for now. Unless you're really interested in knowing what that is, then watch my video on the theory component. But what kind of function do we have? We clearly have a linear equation. So we've got f of x is equal to ax plus b. So we don't know what a is, which is the gradient. Okay, that's the gradient. And then the y-intercept is clearly b. Now it tells you that a and b are non-zero constants. So it means that a and b are not zero. So you definitely have a linear equation. Then they tell you this part, f of 1 equals 2. So they're trying to say when x equals 1, y will equal 2. So essentially they gave you a coordinate. So it's 1, 2. And this one, this is interesting, they're saying the inverse. So you need to find what the inverse function is first. So we don't know what that is. But they say that if you sub x equals 1 into it, then the inverse at 1 will equal to 3. Or essentially the y value, the y will equal to 3. But that y value corresponds to the inverse function. Okay? So find values of a and b. So first things first, if you were to find the inverse, how would you do it, right? Because we don't know what the inverse function is. Well, let's start off by, and I like to do it this way. So I'd say let f of x equal to y. So that way you have y is equal to ax plus b. I just like working with y's, okay? So this is the first step I would work with, and then I'd say to find the inverse, okay, so you can say for inverse transformation, well, you could have just done x comma y becomes yx. Well then, this now swaps the x and y, and you get now x is equal to a times y plus b, okay? And if we were to solve this, this now becomes x minus b is equal to a times y, and then y divide both sides by a, so you got x minus b over a. Okay, so this is technically my inverse function once I rearranged it. So therefore, f inverse of x must be x minus b all over a. Or, if you like to break it out into their fractions, then it's 1 over a times x minus b over a. Okay, so I'm just separating the fractions. Cool? So that's my f inverse. So now I've got both of them. I've got the two equations. I've got f of x, and I now know the inverse is equal to, and I'm just going to write it again, 1 over a times x minus b over a. Is that correct? Just double checking. Yep. All right, so I've got two equations here. Now let's substitute them. So equation 1 says that with the inverse, when x equals 1, the y value should equal to 3. So this is for the inverse function. So inverse of 1 should equal to 3. So f inverse means of 1 means you're going to sub 1 in. So it's 1 over a times 1 minus b over a is equal to 3. Can you see what I've done there? All I've done is I've just taken this equation and I've substituted x equals 1 because that's what this is saying here. Yes, I've subbed 1 in. That's what f dash of 1 is, or f inverse of 1. And then I just carried the equation as equals to 3. So from here, let's solve it. It becomes 1 on a minus b over a equals 3. I personally don't like working with fractions, so I'm going to times everything by a, times this by a, times this term by a, times this term by a, and you get 1 minus b is equal to 3a, and therefore 1 is equal to 3a plus b. Okay, so that's my first equation. That's my first equation utilizing the inverse information. And then I need another piece of information to solve this lot because there are two parameters. There's the a and b that you need to solve. when you have two unknowns, you need minimum two equations. So I've got my first equation over there before, and utilizing my next piece of information, they told me that f of x is equal to ax plus b. And they told me that when u sub x equals to 1, the y value should be 2. So again, I'm saying f of 1 it should equal to 2. But f of 1 would just mean a times 1 plus b needs to equal to 2. See what I've done? I've just essentially said f of 1 means I'm going to sub x equals 1 there. So this equation, I'm just replacing it over here. All right? And then now let's calculate it. So this becomes a plus b equals 2. And that's my second equation. There we go. So I've got my second equation and my first equation, and now I'm going to simultaneous them to solve. So here we go. I like using elimination method. So I probably would say take equation 1 minus equation 2. So I'm just going to write it again. You have 1 equals to 3a plus b, whilst equation 2 is 2 equals to a plus b. Using elimination method, I'm going to find the difference between them. 1 take away 2, so equation 1 take away equation 2, which ends up being 1 take away 2 is negative 1. And 3a take away a is 2a, b take away b cancels out, so a must equal to negative half. And if you know a, well then now you can find b sub a equal to negative half into, I don't know, let's say equation 2. Equation 2 looks easier. So I'm going to sub it into that. And what does that become? 2 equals to a, which is negative half, plus b. And really, if you solve for it, plus half on both sides, that becomes 2.5 equals b, or 512 equals b. Okay, so all I did here was I just said add half, negative half cancels out. Cool. So there we go. We got b equals 512 and a equals negative half, which answers the question, find the values of a and b. So the first step I did remember, I needed to have an inverse function and the original function. They gave us the original function. I didn't know what the inverse function was until I found the inverse. What's tricky here is you're used to having numbers, and you don't always have to have it. You can do it as what we call a literal equation. So it's only an equation with all the letters. So that's what I did here. Found what f inverse is. Then I went back and I substituted the coordinates to find the values. Okay, so that's how you do this question.